I'm going to solve some problems on optical interference, but before that, let me first talk about some interference basics, basic ideas on interference. So suppose if you have one source, so it produces circular waves, right, and that is spread out. Just like if you have a vibrator and if you use a ripple tank, shallow water, right, you can generate the ripple of waves that spread out, right? And this is the wavelength is the peak to peak distance, right? So these solid circles represent the crest, and the dotted circles say represents the trough, right? And this is the top view. Actually, it sends out a ripple of wave, but that's not particularly interesting. But if you have two sources, right, two identical sources in phase, for example, right, then you will see an interesting pattern, and those pattern are because of interference of wave, because they suppose they initially they start out with the same phase, right? They start out with same phase, but since these two waves, right, generated by these two sources have to travel different distances, right? Um, they may meet out of phase, or they may meet in phase at a certain distance, right? If they superpose in phase, right, then at that point you will get constructive interference. So, for example, solid circle meets with solid circle. These, right? These are the points with the constructive interference. However, if the crest meet with trough, so for example, this right here, here, then they meet out of phase, right? So that means these are the points for destructive interference, right? And then you will see this interesting pattern, and then you will see an interesting interference pattern with constructive and destructive interference. And if it is in optical interference, you need a double slit, right? Two narrow slits, two narrow holes separated by narrow distance. And then if this double slit is illuminated with light waves, right, or laser light, then on the you put a screen something somewhere here, and then you will see a bright and dark fringes, right, due to constructive and destructive interference respectively. But the main idea is, as the two waves, right, they travel out with same phase, but as they travel this different distance, they have to travel different distance. This path difference, brings the phase difference, right? And what's the relationship between path difference and phase difference? Right? This is the relationship. Since lambda is a full cycle, lambda will bring 2 pi phase shift. In general, the phase difference between two waves is 2 pi over lambda times the path difference. That's how you calculate, you know. And so using this idea, so in terms of path difference, so this is, let's say phi is the phase shift or phase difference between two waves reaching at any point is 2 pi over lambda, right? And path difference, let's call delta L. So in terms of delta L, so if delta L is m times lambda, right? If the path difference is integer whole number of lambda, right, m can go from 0, 1, 2, 3. Then if you put that here, then they will meet in phase, right? In phase. That means in terms of phase shift, phase difference, it is 0, 2 pi, 4 pi, 6 pi, even number of pi, right? And they meet like this, right? These two waves at that point meet in phase, right? And they produce a constructive interference, bright light, right? So, however, if the path difference is odd half multiple of lambda, right, like this, right, m still goes from 0, 1, 2, 3, right here, odd half multiple of lambda, then it brings the phase shift of this pi, 3 pi, 5 pi, 7 pi, odd multiple of pi. Then the two waves will meet like this, right? Two waves will meet like that, and that produces nothing. And this is called destructive interference. Okay, so this is the basic idea of any interference, right? And we're going to use this in optical interference.